Hi everyone. So what I really want to do with this video today is I want to prove to you why this point in the ISO cost and ISO quant curves is the place it is and how we have the equation we do in order to identify that point. And so the first thing I really need to do that is I need to go back and I need to talk about a specific relationship called the value of the marginal product of labor or the value of marginal product of capital. And so in this relationship, this is represented by the value of the marginal product of labor, and I'll just focus on this for now, is equal to the price of our good on the open market, so how much a hamburger costs, times the marginal product of labor. Let's just say, how many hamburgers can the next person we hire be expected to produce? All right, so what this is equal is the value of that next person is a function of how much those goods that next person is producing are actually worth times how many goods they're producing, or price times quantity. Why I'm saying that is that there's a next step in this logic here, and that next step is you have to say, okay, logically, if we're paying workers right, we want their wages to be equal to the value of what they're producing on the open market times the amount that they're producing, or the value of what they're producing times the amount that that next worker produces. And this relationship, understanding sort of how that is what it is kind of critical. So I'm going to take this the next step. You could have an occasion where, let's say, our wage per McDonald's employee is $10 an hour. And let's say hamburgers on the open market are $7 an hour. And this person produces 3 hamburgers. Like if you hired someone else just now, they would be able to produce 3 more hamburgers every hour. So what we have here is an equation where, excluding ancillary concerns that you're factoring into this, our worker is producing more value on the open market than what we're paying them. And so the logic is that we would have to pay this worker more. They are underpaid. And often you will see this in real life, because if someone is like, for example, working for a company and they don't know how much they should get paid and they don't argue about it and they just sort of waddle in and do their work and waddle out, they may be getting underpaid because the company wants to maximize their profits and their ability to produce and stuff. And so sometimes a lot of these workers will catch on, will actually research their role and what normal people in their role actually are getting paid, and be able to successfully argue for a pay raise. And this is part of the logic that sort of goes into that. All right. What happens to this logic now? And how do we connect it to, again, this graph? And I think I'm going to just keep this graph to the upper left here so that you guys can see it all the time. So we have 2 things going on in this graph. We have wage and rate, and we have capital and labor. Capital and rental rate, wage and amount of labor. Both of those are part of this graph that we're talking about in economics. If you look, the wage equaling the price times the marginal product of labor is also equal to the wage is equal to the price times change in quantity over change in labor. So in that, we have the weight part of the graph, we have the labor part of the graph. And quantity is inherently in there. Remember, quantity is how far the line is from point 0. So this right here is producing much more quantity than this. So we also have quantity in that. Let's do the same thing for capital. Capital is equal to the price we're paying. So the price of our good on the open market plus the amount of production that capital is bringing, which is also equal to the capital equals the price on the open market. And I should actually, it's really rate, it's not capital. Capital is the wrong way to say it. Rate, which is the rate of capital. It's equal to the price on the open market times the change in quantity over the change in capital. That's a better way to phrase it. And notice we have this, and this represented in this graph as well. Now we want to find where they're equal. And where they're equal is where both of these hold true. Because you're producing as an industry, we don't care about output in this question. We care about what's the best combination of weight, rate, labor, and capital. If we cared about output, we'd care about finding the best line of that or the best line of that. And that's not our question here. Our question is what's the best combination of both of those. And so what we find is that we want this relationship to hold true. Because if we're buying another unit of capital, we want the value of that another unit of capital to be what we're paying for it. If we're hiring on another unit of labor, we want the value that the wage we're paying that unit of labor to equal the value that labor brings. When we have both of those, we have the ideal point are in the center. Because we're concerned with both relationships of proper labor and wage and proper capital and rate together, and how we find the best combination of those two factors. What ends up happening then is we're saying algebraically we want our wage to vary with our rate. Because we're concerned with both, we want to find the both when they're both at their ideal point. Or, let's put it this way, we want our wage over rate to equal price over price times marginal product of labor over marginal product of capital. Or, to put it this way, that point right there is wage over rate is equal to marginal product of labor over marginal product of capital. What I hope I've done is illustrated why this really important formula in econ is that, where that comes from, that formula comes from. Because this is sort of the logic you have to follow in order to really get there. Now let's take it one step further. Remember, we're not concerned with quantity. If we're concerned with quantity, we're not really worrying about what different amounts of wages or rates or capital or labor we get. We're trying to figure out what's the optimum quantity that we're finding. It's a different question to say, what is the optimum capital, labor, and wage rate point versus what is the optimum quantity? Do we want to be right here or do we want to be right here? completely different question, and that's why I'm graphing this the way I am, because I want to sort of take the concepts out. And I'm actually writing this wrong. This is labor over wage. This is labor over wage. But I really just want to take those concepts apart. They're two different things, and one doesn't solve the other. So the reason why I say that is we have our formula now. Wage over rate is equal to marginal product of labor over marginal product of capital. We can rewrite that formula to be marginal product of labor over wage is equal to the marginal product of capital over rate. We can even rewrite that formula to equal change in quantity of over change in labor over wage is equal to change in capital quantity over change in capital over rate. If we do this way, what's really happening now is we can have a question where we say, okay, we're paying workers $10 an hour, our wage is 10, but they're only producing 2 hamburgers per hour. We're renting capital per hour by $10, and that capital per hour is producing 35 units of goods. So if we're relating that to this, we get 2 over 10 is equal to, it'd be 10 over 35 is equal to 0.2 is equal to 3.5. This is my argument as to why we're not doing a quantity decision. If we're doing a quantity decision, if we're thinking quantity at all, and we're thinking what is a proper quantity, if that's our question, then we could surmise, okay, this is our labor, this is our capital. They're not at the proper point. Let's increase labor by doing some management program where we're sort of increasing the ability of management to actually produce the good or get their workers to produce the good. What we would be saying is, if we did that, we would be saying we're increasing the marginal product of the labor. We're increasing the ability of management to do that good. But watch what happens when we do that. When we increase the marginal product of labor in this instance, and I'm going to erase this right now, we're not increasing labor. No. We are increasing the quantity that labor is producing. We're increasing how effective our labor is by doing that training program. But notice, if we're increasing that, we're doing something to one side without doing it to the other side. No, and basic algebra. We're doing something to red that we're not doing to capital. And so you could say, okay, let's increase capital. And if you do that, what you're saying is not, let's find the proper point in which capital and labor are maximized. What you're saying is, let's find, say you increase capital, you increase this quantity that capital produce, you run your machines harder. You're saying, let's find, instead of this, let's move this out here. You haven't adjusted wage and you haven't adjusted rate, so the ISO cost curve doesn't move out with it. You're just moving the ISO quant curve. If you say, oh, let's increase both of them because I'm increasing marginal product of labor, that means that the quantity produced by our capital is more efficient, so I'm increasing that, so I'm going to move this out. Because again, what you do on one side, you have to do to the other side. And that's not really the question we're asking when we study this in econ. We're asking for, what is this? And so when, and I'm going to erase a bunch of stuff, when you have these questions in your homework assignment, 9 times out of 10, or almost even 10 times out of 10, what is going to happen is you're going to be adjusting this or this to meet your needs so that these two are equal to each other. I hope that brings it all together for y'all. This is a significant portion of chapter 5. So I recommend really understanding and reviewing this video and really getting it and doing some problems as a result. Thank you.